Greetings and welcome once again to my new calculus site channel. My name is John Gabriel. So you'll notice that in the last 6 videos I've talked about the mean value theorem and different aspects of it and how certain parts of it are unremarkable. And now you might be wondering, what is the correct statement of the mean value theorem? So let's look at it. Now, let's look once again at the mainstream definition. So it says that if a function is differentiable on this interval, in other words, from this green point to this point, it means that there is a point in this interval such that the derivative at that point is equal to the function's, not average rate of change, that's garbage, is equal to the function's level magnitude. Now, level magnitude is the same as an arithmetic mean, okay? We'll get to the correct statement in a moment. But what this means is that if we wanted to find the level magnitude here, just press this button, boom, there it is, okay? So if we wanted to see, so the level magnitude is 21.25. And if we multiply 21.25 by 3, we'll get 63.75, and that happens to be the area, okay? And we can change this to any other curve we like. So let's just delete that and change it to another curve like this. Let's do this. X plus 2, x minus 1, x minus 3. How about that? Okay. So now we have this curve here, and let's just say we want to do that. We don't want to mix areas above and areas below, because areas below are negative and areas above are positive, okay? So if we get a lev mag here, it's this guy here, and that's 21 1/3, right? So we would say, let's just clear it, 3 plus 21 times 2, right? Times 2. So we should have 42.66, which 42 2/3, which is the area. Okay, so as you can see, what's happening here is that in this diagram, okay, this very same diagram that you're looking at, let's just copy it. In this diagram, we have that the lev mag, which is located there, is the arithmetic mean of all these ordinates, okay? And by the way, that is the correct statement. So it's this level magnitude multiplied by the interval width that gives you the area. That is the correct statement of the mean value theorem, okay? So let's look at that. So the correct statement says that given any smooth function, because if it's smooth, it will be differentiable, continuity is not enough. It has to be smooth. The arithmetic mean, or more accurate name, is level term or level magnitude of all the y ordinates in this interval is given by this difference quotient, okay, which is equal to the arithmetic mean, which is f prime of c, okay? So this is the correct statement of the mean value theorem. And by the way, all calculus works because of this. So for example, you can't say something stupid like, a Marcus Cliver thing that the derivative is just an operator, okay? That's just bullshit. You don't do that. That's nonsense. It's not just an operator. When you have a parametric equation of 3t3 and 1 over t and t like that, and you differentiate it, you're using the mean value theorem, okay? You have to use the mean value theorem. And the mean value theorem is a reason that anything in calculus works, whether it's vectors, whether it's line integrals, or Stokes' theorem or Green's theorem. Take away the mean value theorem and you've got no calculus, okay? So you don't get to say, oh yeah, it's just a differential operator. It's not. It's very much based on the mean value theorem. Okay? So this is the correct statement and not this garbage that you see here, which is actually wrong because if C is an inflection point, then there is no so-called average rate of change or the finite difference quotient. Okay, there's no finite difference quotient like this. Okay, so you cannot get f prime of C equals to this if C is an inflection point, and that's what I've showed you in a couple or more of the previous videos. Now, mainstream academics are morons, and because of that, I've had to write this world-class article explaining why the mean value theorem is so important. And I'm going to place a link to this. It's free. You need to study it, especially if you're a mathematics professor or a calculus teacher. This is for you. It was written for stupid people like you. So please feel free to download it and study it. Now, if you're not already a subscriber, become one. Okay? Click like on my videos. Follow me on academia. This is my academia channel here. And to get access to more goodies, just click on join, the join button on any of my videos. Okay? So if you go there, come along here, there's a join button. Just click on this. There's a little fee of $4.99 a month, and you can have access to everything. All right? So I encourage you to join, sign up as quickly as you can, and also become a member of our Discord channel. All right? Discord. This is the new Calculus Discord. I don't run it, but it is the new Calculus Discord. And you will have access to lobby and questions. All right? So now that's pretty much it. If you pass the test, you can have access to all the other channels. That means you need to do a bit of studying, right? And the reason we've got that in place is we want to eliminate most trolls because the internet is filled with trolls. So that's very much it. I am the great John Gabriel, and this is the new Calculus channel. Till next time, goodbye.